Good morning, everybody. Welcome to the MSDN Webcast, Building Metro-Style Apps with XAML, What .NET Developers Need to Know. My name is John Weezy. I'm a Senior Architect Evangelist in our Developer Platform Evangelism group, focusing on Windows 8. You see my contact information on the slide, and just want to welcome you. I said good morning, but of course, if you joined us from other parts of the world, you're probably in the evening or afternoon. And we'll go ahead and get started here with the second in a series of webcasts revolving around Windows 8 development. So, like many of you, about a year ago when I started focusing on Windows 8, the first question I had was, what do I know already that I can use in building Windows 8 applications, and what do I need to learn? And what I found out, and what I hope you all either realize already or will realize by the time we're done with the session today, is that a lot of what you already know carries over to building Windows 8 applications. So a lot of the information and things that you've used to build .NET applications in the past just continues over and allows you to build Windows 8 applications like you have. So let's go ahead and dig in to some of the things that help make that possible. The first thing that we are going to cover here is the WinRT for the .NET developer. The WinRT team has done a great job at making it as easy as possible for .NET developers to build applications, and we're going to talk through some of the things that they've done to make that possible. And then we're going to dig into async. In Windows 8, we want to make as much work as possible asynchronous. If we do that, we free up the UI thread to, of course, allow applications to be more fast and fluid and be more responsive to the user. And we'll talk about how we've enhanced the .NET framework and built things into Windows 8 to make that possible. Then we'll dig into tools. The last thing we'll do is look at some of the tooling and see how some of the changes that have been made within the Expression and Visual Studio teams have led to some great enhancements into Visual Studio for the developer when building Windows 8 Metro-style applications. And again, as I mentioned, my goal here is that when you leave, you will understand the new concepts from a XAML and .NET developer perspective for building Metro-style apps, and that all of your existing skills will carry forward and be reusable for you. So let's dig into WinRT for the .NET developer and talk about the changes that have been made and the things that have been created for Windows 8 specifically for .NET developers. So this first slide here is really, probably the most important slide of the entire deck. A lot of what you've learned over the years as a .NET, C# or VB developer will directly apply to building Metro-style apps. So if you think about the things that you've learned as far as the language goes, whether that's VB or C#, the syntax that's specific to that language, and all of the underlying framework APIs and things that you've slowly learned over the years to apply to applications, all of those will continue to move forward and be applicable to Windows 8 applications. And all you're really going to have to learn is some of the new WinRT APIs that have been added to get at specific Windows 8 hardware features, underlying subsets and things like that of the operating system. We're going to look at how Windows RT or WinRT takes care of that through what we call projections to make that very familiar to you, to look very familiar to you as a .NET developer. One of the things that I want to talk about that helps enforce the familiarity is how we can use WinRT to see the underlying core APIs and things that Windows has available to it that are projected to you. But keep in mind that Windows has always provided features for developers to build upon, APIs. There's always been that underlying API set to help you get at underlying Windows features. The problem that we've had, though, is that while those features are there, and there's some very powerful features that we've leveraged in applications over the years, that they've been hard to get at, and quite frankly made our code look kind of strange Sometimes it's not as intuitive as a .NET developer to write that kind of code. So what the WinRT team wanted to do when they set out to design WinRT for Windows 8 was to design a method that allowed the underlying APIs to appear for .NET developers as if they were just part of the language, just something very simple, and intuitive to us to use. And they did that through the projections and what we call projections. So let's take a look at, what do I mean when I say they created a projection? So if you look at this code, you're going to see that this is actually kind of an anti-example of what we're trying to accomplish, but it helps show the point here. That if you were in C# today, and likewise you could do the same thing in VB, and you wanted to leverage the webcam that's attached to the machine that you're using, you would write code similar to this. You would have to do some DLL imports. You would have to handle the fact that the API that you're calling uses types that aren't familiar to .NET, so you'd have to marshal and take care of all of those sorts of things. And when you're done, you end up with this code that has a lot of this extra stuff in it, stuff that as a .NET developer is just kind of in the way and kind of a hassle to have to learn how to do this stuff. It should be as straightforward as all the other .NET functionality that you already use. And what you're doing, when you're writing all that is you're really, trying to take your managed code and access that API, and you're writing this kind of in-between layer, this manually generated interop code that you're writing to allow the .NET code to get to this traditional Windows API. So you're writing that shim, and as part of developing WinRT, the goal was to make it so that developers don't have to get to that level of granularity, that you can write something that looks very familiar to you and have it work the way that it did in the past without having to write all that extra stuff. So if we kind of carry that example forward just a little bit to what you would get today in Windows RT on Windows 8, you end up with code that looks like this. And what that is doing the exact same thing to get at the webcam and get a picture. But all I've done now is I've added a using statement. And then I'm using an API without having to write all these DLL imports and worry about marshalling and everything, because the WinRT has done this projection layer to .NET to make .NET see all the underlying APIs as if they were just part of the .NET framework. So you can see here that I'm, creating this capture UI, and then I'm setting the size for the aspect ratio that I want to capture, so 4:3 instead of a 16:9, let's say. And then I'm telling it that I want to capture a photo. If I did get a photo back, then I can convert that over to a bitmap, and then I can display that bitmap on my page in this photo object. But you can see as a .NET developer, it looks very intuitive, very straightforward. None of this weird stuff that I have to go figure out how to do for the first time if I have never done a DLL import and tried to call into unmanaged code. It's very, very simple to do. So, that is where the Windows runtime has excelled for .NET developers. One of those great features that we added with WinRT is that shimming layer, that projections, as we call them, from the APIs, where we take all of the API and we project that out in different ways. So if you're a VB developer, that projection makes the APIs just look like they're part of VB.NET. If you're a C# developer, they look like they're just natural C# framework elements. If you're in JavaScript, you get that same projection. So all of those APIs, those underlying Windows APIs, just look like native JavaScript objects and things that you can connect to and use as if they were just part of the language. So that projection layer crosses over everything and allows us to then see that. And here you can see, this is kind of the typical architecture diagram. So we've got our Windows core at the bottom. We've got in the green, you see all of our different namespaces and API that are available. And you have that orange layer, which is that language projection that I was talking about, where the WinRT goes ahead and goes through the system.ui, I'm sorry, the Windows.ui and the Windows.pickers and controls and media, and surfaces the APIs through that projection to your Metro style application via whatever language you're developing it. So again, the goal from the very outset for the WinRT team was to make it feel very natural and familiar to us as .NET developers, so that we can be productive right out of the gate. We're not spending a lot of time learning a whole new platform. We can just basically continue developing, and it's just like learning a small set of new APIs that might be released in the next version of a platform. So if we look at the work that they did, regardless of what the underlying type might be in the base API, it's all projected via that language projection that we just talked about, so that it looks like things that we're already familiar with. And you'll see that throughout the code that you write. As you're writing code, you'll see lots of things where you're hitting the API, the Windows API, but it just feels like it's part of the .NET framework and it's something that's been there all along. I've included at the end of the deck a resources slide. I'll also, when we get to the end, I'll copy and paste all of those resources into the conversation window so that you have those and can copy those and have those links available to you. One of those links is a link to a build session that was done back at the Build conference in September that digs into WinRT and what they've done with these projections and goes into a lot more detail for anybody who might want to learn a little bit more about that part and the things that we've done there. Most of the differences that you will find between the Windows runtime and .NET are hidden because the WinRT will take care of that for you, so you don't have to worry about that. And that comes through some of the things that we'll see here as well. So you'll see a lot of the types that we are familiar with as a .NET developer don't necessarily port over to the Windows APIs. Right? A lot of those are written in C++, and they use a different types than we do in .NET. So in the past, we would have had to do the marshalling. Now, because of the projections and things that WinRT does, those are taken care of for us. So if you take like an I list, right? You would normally write an I list in your application, and that's not going to transfer well over to the APIs because they're expecting an I vector of T. So what happens is you provide an I list, and the projection layer, as it's processing all that, converts that over to that I vector of T and handles passing that then to the APIs. And likewise, coming back, if the API is providing, say, an IMAP back, that gets converted over to an iDictionary, something that, as a .NET developer, we're very familiar with, and can just accept that back and work with it as we normally would. So all taken care of through the projection layer for us. In some cases, there's just not a very clean way to do it. So what they've done is they've tried to take and create extension methods on the APIs to take something that maybe isn't familiar to us as a .NET developer and give us that familiar way to access it. And there's actually only two examples of this in the entire WinRT. So it only happened in two places, so not anything huge, but enough that we want to bring it to your attention so that you understand what they're doing. And one of those places is streams. The other place that we see these is in buffers. So in this case, I'm using streams as an example. And here you see what we're going to do is we're going to use the file open picker. So we're going to, file open dialog in the past. We now call it a picker to create a new file open picker. We're going to add some filters. In this case, we're just saying, all files. And then we're going to say, pick a file async, so single file async. So this is going to go out and it's going to allow the user to then select a file. And that's going to come back through this file.open for read async, which is going to provide us with an input stream, which is what the Windows WinRT API is providing for us. So we get this input stream, but that's not exactly, from a .NET development standpoint, it's not what we're used to using, right? We want to use a stream, which is a regular system.io stream. So what they did is they added this helper function as stream to the input stream API. So we can call as stream on it, and it will return to us what we're used to, right? And it's system.io.stream. So now we have that stream that we can use with the stream reader to read the file in. So again, it looks very nice and very clean. We have just this helper function on the API that we can use to get back what we're familiar with and want to use in our applications the way we've always done it. So a question that I do get quite a bit as I'm working with partners who are developing applications right now for Windows 8 for the store and for future release is, can I create a .NET library in, say, C# that I can use across different projects, whether that's C#, VB, JavaScript, C++, or can I take existing code that I have today and wrap that into a reusable component that I could use in a JavaScript app? Say I've decided that my Windows 8 application that I'm going to build would be better done in JavaScript for some reason. So I want to reuse some of that logic that I've got in, say, a Windows Phone application or my website or a Windows 7 desktop application. And the way to do that is through this process that we've enabled in Visual Studio. So the answer to those questions is yes. Yes, you can do that. And we've provided a way to do that in Visual Studio. There's a couple things that you got to keep in mind when you do that. And one of those is that there's four simple rules that you have to keep in mind. And while I'm going through those, one of the things to think about is this only applies to public types and members in your managed code. So anything else that you do that is not projected external to that component can be done exactly as you do it today. These rules do not apply. So these rules only apply to the externally facing, the projection that you're going to make to whoever's consuming your component. And the four things that you need to keep in mind, and basically the four rules of creating a .NET component that can be reusable in Windows 8 applications, is that all API signatures must use only Windows runtime types. The second thing is that structs can only have public data fields, so no private members or anything like that. Third, all types must be sealed except for XAML controls. And the last thing is that we only support system-provided generic types. So if you keep those four things in mind as you're building your .NET component, and then make a tweak to a setting and such that I'm going to show you here in a second, you will be fine and you'll be able to use your components across different applications on Windows RT. And as I mentioned, the cool thing is that Visual Studio has already, provided mechanisms for us to do this, and has also added in functionality that helps us stay true to those four rules. So when it compiles, it checks to make sure that if you use something like IEnumerable of t, that it will give you a hint that, hey, this isn't going to work. You need to project out, and you need to be using IIterable of t. So that I can then project that in the proper way to each of the other languages that might consume this application or consume this code. So really great support from Visual Studio to help us with things like that. So I'm going to switch over to my desktop and walk you through a sample of a WinRT component in C#. Move some of these out of the way and pop this up here. So if we kind of zoom in over here in the top right, what you'll notice is that I have a project here. Actually, I have two projects in this solution. The first one at the top, the CS WinRT lib, is my Windows runtime library that I've created, consisting of just a class. And then the second one is a JavaScript project that's going to consume that. So if we look at the class, let me zoom back out here. You see that there's a couple things. The first thing is that the class is sealed and it's public. So I have this already following one of my 4 principles there, that I have everything sealed. If we take a step back and I just go into the properties for this project, the other thing that we need to do is right here in the application settings is there's an output type, and we've added in this output type called WinMD file, a Windows metadata file. So instead of creating just a typical DLL, this is going to create a DLL that the WinRT can actually consume and then create the projections for whatever type of application is going to use your component. So one of the steps is, of course, to make sure that you've created this as a WinMD file. And if we go through here, you'll see that I have a pretty basic class here. It has a public string called appName that returns an application name. I have a list of groups. So we can see my structure down here. Again, no private members. Everything's public here. So I have a group consists of a name and a count. And then up here I have a getGroups function that can be called on my object, which will return a list of groups. So if you've built any Windows 8 applications thus far, you probably kind of get an idea of what I'm doing. I'm creating the data that will be used on the main screen of a typical grid application in Windows 8. So I'm able to get the application name, to place that in the title area, and then I'm going to get my groups, and I'm going to use these here to create a group, or in this case 2 different groups, and then the count is how many objects I want to show up in each of those groups. So if I move down here, you'll see that I have a reference to the CS WinRT lib in my references. And if I go down to my page, see nothing spectacular here on the HTML side, but if I go into the JavaScript side, we'll see that what we're doing is we're populating our groups by calling the WinRT library, our class, and then the getGroups. And that is it. All we're doing is pushing each of those in to see them. So let's go ahead and see how this runs. It's a very straightforward application, but just a good example of using that. So if you see here, the My Hybrid App title is coming from the application, or from the library. And then we had the 2 groups. The first group had 4 items in it, so the count. And then the second one had 5. And that's how we built this application. So we built this application using the information coming out of our component that we've built and could share across. So again, a HTML JavaScript application consuming a .NET library, and pretty straightforward, simple to do. Just follow a few rules and away you go. So let's jump back over to our slides. All right. So the second piece that we wanted to talk about was asynchronous, and how we want to be more asynchronous. And that, as I mentioned early, in the agenda, one of the things that we talk about frequently when we talk about Windows 8 is that Windows 8 is fast and fluid, and in order to help developers create fast and fluid applications on Windows 8, we've added some capabilities into the .NET framework that's coming out in conjunction with Windows 8, and one of those capabilities is async, the asynchronous programming model. And a common scenario, is that in an application is that when the application loads, the first thing that we might go off and do, or typically go off and do, is that we're going to go get data from something. We're going to go get it from a remote web service, a local database, from the file system, and so on. And these things tend to take time, especially if we're talking about a really large data set. And it hasn't been cached before or anything like that, so we're pulling down a lot of data. And when we do that, if we aren't doing it asynchronously, it's running on the UI thread, which is going to drain the application. And the users aren't going to be able to have it respond when they click or drag or do anything like that. So by moving it off that UI thread using asynchronous programming, we can make the applications more responsive. And when we get them more responsive, they become more fast and fluid, and the users really feel like the application is responding and doing what they want it to do, even while it's off and getting some data. So when we talk about synchronous versus asynchronous, and the problem that we're trying to solve here is if we look at this first code sample at the top, what we want to do is we want to get some data. And this is doing it synchronously. So we're going to go off and download data, and then when the data comes back, we're going to process that data. So when we think about doing that synchronously, what happens is we make our call to download data, and then we wait. And we wait until the data is done downloading. So if you think of, say, a service like a Netflix, thousands and thousands of movies out there, and we're building a Netflix catalog viewer app. And the first thing we do when we launch the app is we go off and we download all the thousands and thousands of movies that they have. And we're downloading the image for each of them. We're downloading all the data that they have for each of them. And then once that's done, then we can display that catalog to the user. That could literally sit there for minutes on end waiting for all that data to come down before it does anything else. So as a user, I'm clicking around trying to do things. Maybe I can't even switch out of the app because it's tied up the system so bad. Things like that are somewhat commonplace today. So what we want to do is we want to make those asynchronous so that we can avoid some of those pitfalls. So if the second code example shows us how we might do that, right? We might have a function called download data async. And what's going to happen is when that data finishes downloading, we will come back and process it. But in between, the system will remain responsive because this is going to happen on a different thread than the UI. So the user can still maneuver within the application. They can still use their system without the resources being drained and things like that. So when we think about how that happens, is we go ahead and we make our download async call. When the data comes back, we process it. But in between, we're not stopped. We're actually able to do other work. And if we design our applications right, we can make the application continue to be usable, and as data loads, it becomes visible and accessible to the user to help make our applications more fast and fluid. In the past, we've seen a lot of different ways to do asynchronous programming. We've seen things like the Windows runtime that we're talking about now has this iasync operation of T, and has actually a couple of variations on that. We've seen the .NET framework has a task of T, and we see in JavaScript that there's promises. That's how the JavaScript works. And these are all really good ways of doing it. And they all have one thing in common, and that's that they have an ongoing operation, and they use a callback to signal the completion of that operation. So, one of the problems with callbacks is that it turns our code kind of inside out. We see a lot of lambdas in our code. Then, if we're developing callbacks, we might have functions someplace else in the code that we got to go find because we've chosen that method of how we develop callbacks. So it makes it a little hard to follow our application and understand that it is doing something asynchronously when we've written it that way. And what it also makes it hard to maintain and debug. If I have a new programmer coming into my team and they need to go and maintain some code that was written before, it may make it hard for them to try and follow that code. So what we wanted to do with the .NET programming languages moving forward was we wanted to provide a means of doing that work asynchronously and free up that UI thread, but do it in a way that looks like synchronous code and looks very natural for .NET developers. A couple of the things that we did and that you'll be seeing in the code, and as I go through the sample here, and as you're writing your own applications, is that we have a new async modifier for our methods. So we've added the ability now to mark a method as asynchronous, that it should be able to be called asynchronously. We've added return types that are specific in Windows 8. So we added that you either return a void or a task of T when you have an async method. We've added an await operator. So when you are going to call an asynchronous method, you put an await keyword in front of it, in front of that call, to alert the the runtime that you're making an asynchronous call, and anything after that should happen once that call returns, but it should be done on a separate thread, and then response coming back to the system as you would expect, so that it remains responsive. We do this, using regular programming constructs, so nothing fancy, none of the old DLL imports or marshalling or anything funky there. It's all very straightforward, regular programming stuff that we do today, and looks just like good old synchronous code. So let's take a quick little look at async in a WinRT application. Switch back over to my desktop and pull up that sample. So I'm going to run this, show you what it's doing, and show you where the async comes into play, and then I'll show you some of the code. I mentioned before, that it's about Netflix as my example for loading a lot of data, and that's not good. All right, let me try this again and talk through this as I'm going. So Netflix has this really great OData feed, and what they do is it doesn't want to run on my machine. All right, I may not be able to run this one. Let's go see. So they have a really great OData feed that provides all of their catalog information in a feed that you can access. We've used it in a number of examples before, and what I'm going to do is try and manually load this. Let's see here. Nope. All right. Not going to let me. So I won't show you it, unfortunately. It was working yesterday, and now it's not failing. So let me go back into it, and I will just show you the code. There we go. All right. So as I mentioned before, there's a couple of the keywords that you're going to use in Visual Studio as you're developing asynchronous applications. So the first thing we'll do is we'll do a look for these. Find. All right, let's go to this one, show you what the code is doing. So here we are, we're in the movie groups page, which is the default page that we come into in an application. And we are in the on navigated to, which is what fires when an application or when the page gets loaded and navigated to. And you'll see that we're doing this initialize async. So this isn't asynchronous, it's just a regular call to this async method. Now it's labeled as async, so it could be called asynchronously. And inside that, we are calling this load group images async off of our data model. So you also notice that we've got the await keyword in front of it to tell it that it's asynchronous. If I move into this one, you'll see that we then carry this asynchronous model even further by asynchronously loading the image for each movie in the list that we are processing. So we go through and we process that. And here we're going ahead, you see we're returning just a basic task. And what we are doing is populating out the image for each movie. So we're going ahead and setting the URL to whatever the URL is and that's coming back and being populated for us to use. So very straightforward, and I will try once more just to see if it'll run. So let's see. Yeah, no, doesn't want to deploy on my machine for some reason. All right, if I do that, no. All right, so I'm not going to waste time trying to fix that one for you, but I will talk through that. I talked through that one for you, so hopefully that one is fairly straightforward. Again, it's just using that async keyword on your method, returning either a task of T or void, and then when you are making a call into a synchronous method or an asynchronous method, to label that or preface it with the await keyword, so that the runtime knows that you are calling asynchronously, and then this code after that line doesn't execute until it comes back. So that's how simple we've made it to do the asynchronous programming. Let's jump back over to our slides. Yep, that's what I'm on. There we go. Now let's dig into the last topic, which of course is tools. Try that again here. There we go. All right. So here we're going to talk about the tooling changes, in particular Visual Studio and what we've done there. So the Visual Studio Designer, one of the really cool things that we did with this release is the Expression Designer team, so the folks that design the surface area, the designer piece inside of Expression Blend, and a lot of the tool itself, merged with the Visual Studio Designer team. So the two teams became one. And the great piece about that is that you now have a single designer that is supported across all of the different languages, C#, C++, VB, in Visual Studio and Expression Blend. So you just have one designer now that is the same across both. Because of that, we have this core authoring UI experience now between Blend and Visual Studio, which means that we have consistent XAML parsing. We have, of course, a shared UI where it makes sense, but we also continue to have each tool optimized for that target audience and workflow. So Expression Blend geared at designers, Visual Studio, of course, geared at developers. But knowing that when you learn how to edit, say, a template on a control in Expression Blend, that same steps, that same process applies in Visual Studio, or vice versa, is of course key and a very big gain for us as developers. So I've got a demo of that to show you, and I'm just going to walk through a bunch of features and show you all these changes in Visual Studio, and then we'll come back to wrap up. So let's go ahead and jump over here and go into the XAML. All right, and what we're going to do is I'm just opening up the project here. It's just a basic Visual Studio template. So I'm going to open up the page, the default page that we land on, the grouped items page, which is the default page in a grid template, and it's just going to load up the designer. And while that's loading, I'm going to show you a couple of things that we can look at here. So we'll notice that the toolbox, of course, we have our XAML tool controls now. We have our common, so all of our controls come over. Just as you'd expect, so nothing new there. But one of the really nice things is we now have a document outline. So if we are looking here at the XAML, I can actually go into, say, the grid, and I can start expanding this out, and I can turn items on and off like I could in Blend. So as I hide the back button, it disappears, and if I show it, it comes back up. So some great functionality that used to be in Blend only, now in Visual Studio. Same thing with the title, I can hide and show that. Any of the controls I can hide and show. What I can also do is go over here, and this is new in this version as well, is this platform tab. What the platform window allows us to do is simulate running in different states and see what things would look like. So I can go into, say, a snap state, and I can see what this page will look like. So I can edit as if I'm in a snap state and edit my page and see what that would look like without having to actually run the application. I can do the same thing for portrait mode. So actually let me zoom this out a little bit so that you can see it. But if I go into portrait mode here, you can see that I can design my application as if I was running in portrait mode without actually running the app. I can also change my screen resolution. So if I wanted to say, see what this might look like on a 27-inch screen, I can then kind of see what this application would look like, and I can design it now looking at it as a 27-inch screen. So the great functionality here with the platform window. Show Chrome is just going to remove that border that shows kind of like the bezel of the display. So if you don't need that on there, don't want it on there, you can turn that on and off. It has a couple other things. I could choose different themes. So if I want the light theme, I can make changes to that as well. And then I get different themes, which you see the text changed in the top left there. So different things here. And now that I'm in high contrast, I now get this kind of greenish border around the items as I'm zoomed out here. You can see. So great thing there with the platform thing is window as well. And if I go back over here to document outline, and let's go to like the pages root here, and let's go back up, page root, come on. There we go. All right, and I picked the back button, or actually in this case, what I prefer to do is just go and I don't want to lock everything, so I'm going to unlock. And I'm going to go back to page root, and I'm going to come over here to the properties window and show you how we brought this over. So if I open up brush, you'll start to see, and let me close the Solution Explorer there, how things look similar to how they did in Blend. So if I open up the project here, I'm editing the actual page layout here. I could change to a background of, say, red. I could change let's change the page title. So I could change the foreground color of my page title from in here, just like I would in Blend. I have all the controls and things that I have in Blend now available in Visual Studio. So I can, of course, change name properties. I can change the fonts and all those things here in the properties window that looks just like it did in Visual Studio, or I'm sorry, in Blend. A few other enhancements. If we zoom back in here on this grid, let's go ahead and grab the grid. And if I zoom back in, just by scrolling my mouse wheel, you'll see there that I get some pop-ups because I'm over the grid here, which is a column in a row, and I have options here, so I can change my formatting directly in Visual Studio in the designer. I don't have to go to the properties and change it there, or change it in the XAML. If I wanted this to be, I could do that, and it's going to change it right here for me. So all of my changes happen real time. I can add more columns just by clicking. A lot of this has been here before, or this piece has anyway. So there's some things there that you can see. there's quite a bit of new things in here in the designer that you could go ahead and play with. We have, just for example, I'll go through some of these. We have the ability to control click in the toolbox to make something sticky now as far as drawing objects. We can select borders, and we can edit the brushes directly. So you can see here, if I wanted to change this one, I could come into a brush here, and I can actually change this to be a custom expression. I can load it from a local value. I could create it from a system resource. I could do it via data binding. So a lot of things that we could only do in Blend before, we can now do, or do through code or XAML, we can now do in Visual Studio through the properties because of the fact that the designer teams have merged. All right, so let me jump back over and we'll do the recap, and then I think there's a bunch of questions out there, so we'll get to those. All right, so there we go. So to recap, you know, we had those three sections. And of course, the key thing is that, you know, you already have the skills to build metro-style apps if you're a .NET developer. And hopefully, you know, you've seen through the stuff that I've told you today, or that you've seen online or read in the months previous since our build conference that is the case, that you really do have everything you need to build applications if you're a .NET developer today. Sure, there's some new APIs that you have to learn, but you know that's going to be there with any new version of an operating system or a framework. There's always going to be new APIs. The key is that all those existing skills that you have will continue to be usable in conjunction with those new APIs, and that the WinRT team has created this projection layer to make all those underlying APIs seem more natural and intuitive to you for using those in your apps. WinRT was influenced by C# and VB, which is part of the reason that it feels natural and familiar from those languages. They kind of took the approach from the .NET developer side as opposed to from the API side, and then worked the other way to make them appear back. And one of the other enhancements that we did talk about that I don't want you to forget is that you can build your own managed Windows runtime components. So you can build your own WinRT components that you can use within applications as you're building them. Of course, async equals no more callbacks. Yes, very, very good. The new async keyword and the await keyword that goes with it, and all the new asynchronous programming model that we have, you know, make it very easy to do. And then I encourage you to learn more about those and use them to make your apps much better and be fast and fluid on Windows 8. We talked about the tools, and what we want there is we want you to work visually, because you can be more productive when you're working visually, especially if you're just trying to edit the look of a page. Edit the XAML directly if you want more control, but you can edit visually. And then use the templates as a base structure for your app. So use the templates, create, copy the template to edit it and make changes to make your own look and feel, but use the templates as a base starting point because they have a lot of great stuff in there for you to use and to build your apps off of. And finally, we have our resources. I'll leave this on the screen for you. I'm also going to paste these into the window so you can actually just copy and paste them if you want. But we've got about 10 minutes here, so I'm going to jump over to our window here and see what we've got. All right, so we've got a couple here. Let's see. Mark asks, why do a grid view and a list view coexist instead of a single lookless list view? Let me see. I might have to. Let me see if I have more info. With different portrait landscape item percentages. Okay. What does it mean when we're developing our own portrait landscape? Yes. So if you have played with the in the .NET side, if you've played with the templates, you'll notice that the default for full screen is grid view, and the default for a pinned mode is a list view. And that is just because of the nature of the template and the way that we design those templates to act. So grid view is designed to have, just what you would think, a nice big grid. It could be redone in kind of a smaller grid. We could have also taken the approach of the JavaScript side, because on the JavaScript side, they did kind of do that. On the .NET side, we didn't, and I don't know all the details on that from the product group, but I know that there were some constraints that they were under as to what they could do with the grid view versus list view. So in the templates and the way we do it is we actually differentiate those two because it makes sense to do it that way, to have that grid that has this kind of long flowing capability versus a list, which is kind of a one column straight down sort of thing, which fits that pinned mode paradigm. So hopefully that answers your question, Mark. Let's see. Does the platform screen resolutions choice only work for WinRT apps? Good question. Yes. I don't know the answer to that one because I have not tried to build any other applications in Visual Studio 2011 or in Visual Studio 11 that are non-WinRT apps. So I don't know if that will work in web apps. Yeah, I don't know if it does or not, so we could try it. But if there are no other questions, I'm not seeing anything else in the list yet. So, all right. Yep, no more questions in there. So let me go ahead and actually, before I forget, let me copy and paste the links into here for you, so that you have them. There we go. So just looking through the links quickly, the first two are our base links. The dev.windows.com is where all the developer information is. The design.windows.com is where all the designer information is, so all the great information about how you should design and think about building Metro applications for Windows 8. And then we've got some of the links that I referred to in the session. So you have the lap around Windows runtime. That's kind of the deeper dive into the WinRT. You have the async everywhere talk, which is, of course, again, going to dig into all the async. You have the tools for building Metro style apps, which is going to dig deeper into the changes in the tools and what's available to you. And then the last link is was a recently published content that we put out there. So we've been running some camps around, some invitation only, and now we're starting to do open enrollment camps, Windows 8 camps, and we published that content for you, and it is actually part of the content that we're using for this series. So if you go digging through that content, you'll probably find a talk similar to this one, where you can find the deck and information, hands-on labs and whatnot. Those are based on the consumer preview, and you can get all that information from that link. So I wanted to share those with you. But let's go ahead and let's just try and build a new project and see if that works. So I'm going to do a new project, and let's see. Oh, shoot. Yeah, I can't. I'm sorry. I forgot about that. This is only the Express version of Visual Studio on this machine, which means I can only build Windows 8 WinRT applications. So I can't actually try that for you. Sorry. But you can try that on your own. Pretty straightforward. Just build a new website project in Visual Studio 11 non-Express versions, so a Pro or Ultimate or anything like that if you have an MSDN subscription. And go ahead and see if the platform tab is available to you on that machine while you're building that app. I don't believe it will be, but it might be. I might be surprised. So haven't tried it, wouldn't need to go and find out. Let me take one more look here, and No other questions, so we have about 5 minutes left, but with that, I will go ahead and wrap up this MSDN webcast, and thank you all for attending, and hopefully you learned a bit about WinRT and async and the new tool changes in Visual Studio to help you build Windows WinRT .NET applications for Windows 8. Thanks for joining.